In this video, we're going to go ahead and take a look at two-dimensional array. If you remember, we mentioned that we can go ahead and use this tree visual to also represent a two-dimensional array. So what we have here is a 2 by 3 array. So here's the first row, here's the second row, and each row contains 3 elements. And so what happens is this could as well be a 6-element one-dimensional array, or we could actually go ahead and make it a 2 by 3 two-dimensional array, and the only thing that we're gaining here is just a different way of organizing the information, in a sense having bookmarks that are pointing us to each of the different sets. So if we were to go ahead and take this visual and expand it out, we'll get something like this. So here would be the first bookmark pointing to the first set, the second bookmark pointing to the second set. We're not going to go ahead and talk about this item right here and also this item. We'll get to those later. So really the entirety of this two-dimensional array is what the boundary is surrounding it. So once again, this is the first set, this is the second set. Now we've just gone ahead and populated this two-dimensional array with a string. So the first one being hi, the second one being ma. And of course, being that it's a string, notice we have it in double quotes, it's going to go ahead and place a null at the very, very end to indicate that the string has been terminated. Now, what you will notice is because we're dealing with a character array, each one of these elements is going to go ahead and take one single byte. So this is sitting in location 1000, 1001, 1002. And as you remember, we said that things are being stored in a consecutive sequence in memory, and so after 1002, when we go to the next set, it's going to be 1003, 1004, 1005. You also notice that when we're looking at the different bookmarks, the first bookmark is going to go ahead and point to the first set, which is 1000. The second bookmark is going to go ahead and point to the second set, which is 1003. So the numbers that we're seeing here, the 1000 and the 1003, this is dependent on the number of items that we have in each set, whereas the numbers that actually appear here, the 1000, 1001, 1002, they are dependent on the number of bytes that it takes to go and store a particular element. So this is a char data type, and so it each takes one single byte. So this piece right here is not dependent on the data type itself only, but rather it's the data type in conjunction with the number of items that we have in each set. So with that in mind now, what we want to do is we want to go ahead and take a look at both the array notation and the pointer notation. Now, the array notation is something that we have seen like array 00, array 01, array 02. That would actually go ahead and get us access to these items. And of course, we could actually go ahead and use the ampersand notation, prefixing this bracket syntax to go ahead and get a hold of the addresses. And the same thing is true with these other ones as well. Now, if we want to go ahead and use the other type of notation to get a hold of this, we're going to go ahead and use a series of pluses and asterisks to get a hold of this. As you will remember, we came up with a simple rule with regards to using the plus and the asterisk, or rather the pointer notation. And that is what we do is we go ahead and take the information from the previous row, and if we have a plus, we're going to go ahead and just add the index. So in this case, this is row 0, this is row 1, so the index would be 0 and 1. And when we move on to a column that actually contains the asterisk up at the top, once again, we move the information from the previous row, we wrap it in parentheses, and prefix it with an asterisk. So what we have here is array is being moved plus 0. That's what we have, which is equivalent to this notation right here. We can take this, move it to the next column, wrap it in parentheses, and prefix it with an asterisk. If we were to go ahead and follow through, let's just say that we are now interested in getting access to this item right here. So we're going to go ahead and take the item from the previous column, which is this, and then we're going to go ahead and say plus 2. And so that will go ahead and give us the 1002. If we want to go ahead and get access, for example, to that null, we go ahead and take the asterisk with the parentheses array plus 2, array plus 0, and then close parentheses plus 2. We move that on over, and then we wrap it in parentheses and prefix it with an asterisk. So let's go ahead and just do the 0th item, for which we actually have the complete notation for. So array plus 0, then plus 0, which is what we have, and then we take this whole entire thing, wrap it in parentheses, and once again prefix it with an asterisk. So we can apply this particular rule to really arrays of any dimension, as long as we remember the basic rule of using the plus to go and add the index, and then with the asterisk we just prefix, we just go ahead and wrap the items from the previous column in parentheses and then prefix it with an asterisk. Now, one question that actually comes up is what happens if we want to go ahead and point to a two-dimensional array? Well, if we want to go ahead and point to a two-dimensional array, what needs to occur is that, so let's just say that we want to go ahead and take this address and place it in this variable. And we're thinking, well, here we jump one time and then we jump twice to get access to the character. But if we were to go and just sort of consider just a double pointer syntax, what we would be missing from that syntax would be the number of jumps that we would, or the number of bytes that we need to jump from one bookmark to another. You notice that here we go from 1000 to 1003, which is dependent on the number of items that we have in each row. So what we're going to do is we're going to go and introduce this syntax right here. In this syntax we're saying that we have this pointer array, and it's going to be a pointer to an array that's got 3 elements. So this thing right here is going to go ahead and point to 3 elements. And so in this way what happens is we can go from the 1000 to the 3 character bytes to get us the 1003. So embedded in this information is the bookmark information that would otherwise be missing if we were to just go and use a plain double pointer syntax. So if we were to go down here for a moment, what we have here, for example, is if we go ahead and declare a two-dimensional array of ints, we cannot go ahead and use a double pointer syntax to point to this array. What we need to do is we need to consider the bookmark notation, the bookmark jumps, and that requires that we actually go ahead and consider the second dimension and the brackets, and of course this is going to go and just point to a 3-element set. Now, one question that you may be asking is, why is it that we are not concerned with the number of sets? And the reason is because, as you well remember, we indicated that C does not really care about boundaries. It doesn't do any bounds checks, and that is something that is dependent on the programmer. But the bookmarks is not dependent on the number of sets. The bookmark is dependent on the number of items that we have for each set. So whether we have 1 set, 2 sets, or 3 sets, we don't really care. What we care about is, as we move from one set to the other, how many bytes are separating the two. So hence we have this kind of syntax. Now, if we want to go ahead and convert, let's say, this two-dimensional array into a single-dimensional array, then what we could do is we could actually go ahead and point to the beginning right here, which is this address, and this address, of course, is the address of a char, and of course this address is also being held here, which is the first bookmark. So I could actually go ahead and take this information and store it in a variable, and in this case I would be pointing way up at the top, and then I would be able to go and use the indexes 0, 1, 2, 3, 4, 5 to go and traverse through all the items. Of course I would be losing my bookmarks. So the way that we do it is we come over here and we say, alright, so what is the syntax that's needed to go ahead and point to this content box, and that would be array of 0. And so there we have array of 0. And so exactly what is contained in here? Well, in here what we have is that address, which is the address of a char, and so there it is. This variable is able to go and hold the address of a char. And so we have seen now how we have a two-dimensional array, how the bookmarks are set up, how we're able to go ahead and declare a variable that's able to go ahead and point to a two-dimensional array, considering, once again, the second set of brackets and the number that goes in between, and how we're also able to go ahead and take a two-dimensional array and convert it into a single-dimensional array. To go ahead and finish up this conversation, if we were to go ahead and now pass a two-dimensional array, notice that what we have here is we go ahead and just refer to the name of the array, and then over here on the receiving end we need to catch it. So what exactly is being sent when we go ahead and just refer to the name? Well, we have that syntax right there. When we are actually doing an assignment, notice an assignment is really the same thing as a function call and a function header. So array is being assigned to this variable, which of course is the same thing as that. So if we can understand this assignment statement, then passing an array across functions, its syntax is also going to make sense to us. And then here is an example of how we go ahead and just send that beginning address, which of course is right here. If we're sending this beginning address, which of course is coming to us from here, which is the address of a char, then since we're sending the address of a char, then we need to receive the address of a char, or in this case we're actually saying the address of an int. And so that's the basic idea behind two-dimensional arrays.